Next up, let's dive into deploy and manage Azure Compute resources. The custom script extension downloads and executes scripts on Azure Virtual Machine. The extension is useful for post-deployment configuration, software installation, or any other configuration or management tasks. The custom script extension downloads and executes scripts on Azure Virtual Machines. This extension is useful for post-deployment configuration, software installation, or any other configuration or management tasks. Scripts can be downloaded from Azure Storage or GitHub or provided to the Azure portal at extension runtime. Custom script extension integrates with Azure Resource Manager templates and can be run using the Azure CLI, PowerShell, Azure Portal, or the Azure Virtual Machine REST API. For this exam, be aware of the tips and tricks in the hyperlinks noted. In that article, make sure to make note of the notes. These will help you out. Here are a few of the tips and tricks worth mentioning to know when using custom script extensions. Write scripts that are idempotent. This ensures that if they're run again accidentally, it will not cause system changes. Ensure the scripts don't require user input when they are run. The extension will only run a script once. If you want to run a script on every boot, then you need to use the extension to create a Windows scheduled task. Custom script extensions does not natively support proxy servers. However, you can use a file transfer tool that supports proxy servers within your script, such as curl. Custom script extension will run under the local system account. The custom script extension configuration specifies things like script location and the command to be run. You can store this configuration in configuration files specified on the command line or specified in an Azure Resource Manager template. You can store sensitive data in a protected configuration which is encrypted and only decrypted inside the virtual machine. The protected configuration is useful when the execution command includes secrets such as a password. These items should be treated as sensitive data and specified in the extension's protected setting configuration. Azure VM extension protected setting data is encrypted and only decrypted on the target virtual machine. Property names are case sensitive. The command to execute value can be set in either public or protected settings, and the extension will reject any configuration where the values below are set in both public and protected settings. Using public settings may be used for debugging, but it's recommended that you use protected settings. Make note of that. Public settings are sent in clear text to the VM where the script will be executed. Protected settings are encrypted using a key known only to Azure and the VM. The certificate used to decrypt the encrypted values is stored on the VM and used to decrypt settings if necessary at runtime. Make sure that you check out the tutorial link which uses Azure Virtual Machine extensions to perform post-deployment configuration and automation tasks on Azure VMs. Azure Kubernetes Service, or AKS, makes it simple to deploy a managed Kubernetes cluster in Azure. AKS reduces the complexity and operational overhead of managing Kubernetes by offloading much of that responsibility to Azure. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance for you. The Kubernetes masters are managed by Azure. You only manage and maintain the agent nodes. You can create an AKS cluster in the Azure portal with the CLI or template-driven deployment options such as ARM templates and or Terraform. When you deploy an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. Additional features such as advanced networking, Azure Active Directory integration, and monitoring can also be configured during the deployment process. Windows Server containers are supported in AKS. Kubernetes uses Role-Based Access Control or RBAC. This control mechanism lets you assign users or groups of users permission to do things like create or modify resources or view logs from running application workloads. These permissions can be scoped to a single namespace or granted across the entire AKS cluster. With Kubernetes RBAC, you create roles to define the permissions and then assign those roles to users with role bindings. Before you assign permissions to users with Kubernetes RBAC, you first define those permissions as role. Kubernetes role grants permissions. There's no concept of a deny permission. Roles are used to grant permissions within a namespace. If you need to grant permissions across the entire cluster or to cluster resources outside a given namespace, you can instead use cluster roles. A cluster role works in the same way to grant permission to resources, but can be applied to resources across the entire cluster, not a specific namespace. Once roles are defined to grant permissions to resources, you assign those Kubernetes RBAC permissions with a role binding. If your AKS cluster integrates with Azure Active Directory, bindings are how those Azure AD users are granted permissions to perform actions within the cluster. If AKS is something really new to you, it's worth taking a look at the how-to guides in the docs. There is a lot to this section, so I highly recommend downloading the PDF from the slide, unless you're pretty well familiar with AKS already. Containers are becoming the preferred way to package, deploy, and manage cloud applications. Azure Container Instances, or ACI, offers the fastest and simplest way to run a container in Azure without having to manage any virtual machines and without having to adopt a higher level service. The AZ container create command, as shown on the slide, specifies settings for a new virtual network and subnet. You provide the name of a resource group that was created in a region where container group deployments in a virtual network are available. You can also deploy a container group to an existing virtual network by using a YAML file, a resource manager template, or another programmatic method such as with the Python SDK. You can also deploy from the Azure Container Registry. Configuring liveness probes. Containerized applications may run for extended periods of time, resulting in broken states that may need to be repaired by restarting the container. Azure Container Instances supports liveness probes so that you can configure your containers within your container group to restart if critical functionality is not working. Readiness probes. For containerized applications that serve traffic, you might want to verify that your container is ready to handle incoming requests. Azure Container Instances supports readiness probes to include configurations so that your container can't be accessed under certain conditions. Start-stop. The restart policy setting of a container group determines how container instances start or stop by default. You can override the default setting by manually stopping or starting a container group. Note though, if your container group is configured with an IP address, that IP address can change when the container group is restarted. You can use the AZ container command with the start, stop, or restart. Update. To update an existing container group, issue the create command and specify the name of an existing group. You modify or add at least one property of the group that supports update when you redeploy. Certain properties don't support updates, and you'll want to read that article for more. Set other properties with the values you provided previously. If you don't set a value for a property, it reverts to its default link. Here's a pro tip. A YAML file helps maintain a containers group deployment configuration and provides a starting point to deploy an updated group. If you use a different method to create the group, you can export the configuration to YAML by using AZ container export. Automate deployments of VMs. So in this little walkthrough, we just kind of show some of the ways that you can create templates and modify and take a look at them. One of the simplest ways is to go to the Azure portal and simply type the word template, and you see template deployment appear. And this describes what they are. So if you haven't done these before, you should understand templates use a JSON description of the resource and their deployment settings. And there's IntelliSense, that's just kind of a cool feature that you also have to help auto-populate fields. So in the next thing, you can edit this, and you see that the ARM templates have these four basic sections: a schema, the content version, parameters, and resources. From the marketplace, you can actually select a Windows virtual machine, or you could get these from the Quick Start templates. But the idea here is not to know what all these are, but to understand how they're broken down between the parameters, variables, and resources. So there is an ARM template walkthrough that you'll definitely want to take a look at. When you deploy a scale set, you also have the option to deploy within a single placement group per availability zone or multiple per zone. For regional scale sets, the choice is to have a single placement group in the region or to have multiple ones in the region. For most workloads, we recommend multiple placement groups, which allows for greater scales. So a lot of great links here. You want to take a look at these on both deploying and configuring scale sets. And also the image on there, when you click on that link, it'll take you right to the documentation, which is really fantastic. Azure Backup supports backup of Azure VMs that have their OS data disk encrypted with Azure Disk Encryption, or ADE. ADE uses BitLocker for encryption of Windows VMs and the DM-Crypt feature for Linux VMs. ADE integrates with Azure Key Vault also to manage disk encryption keys and secrets. Key Vault encryption keys can be used to add an additional layer of security by encrypting the secrets before writing them to Key Vault. Make sure you read these notes as well on the links.